So here we go. Question 7. Brooklyn has 8 pieces of strawberry-filled chocolate, 7 pieces of white chocolate, 5 pieces of dark chocolate. All of them are different in size. Okay. The chocolates will be placed into 4 different colored boxes, pink, red, yellow, and green, with 5 pieces of chocolate in each box. Okay, does that work out? Yeah, it's a total of 8, 7, and 5. That's okay, 20. Okay. Brooklyn will give 1 box to each of 4 friends. Okay, there's a lot of choices about to happen here. Uh-oh, typo, Brooklyn. So, just jumping ahead, what is 7b going to ask? How many ways can Brooklyn do this? So I assume put the chocolates into boxes and decide which box goes to each friend. So that there are no more than 3 pieces of dark chocolate in the pink box. Okay. So, first things first, we're going to have to break it down into cases. Okay, no more than 3. Well, we don't like no more. We like to know, oh, exactly this many or exactly that many. Okay. One thing we've learned in the past is sometimes when they say no more than or at least or something like that, makes us think maybe we can do the question backwards. We can figure out the total number of ways for Brooklyn to just split up the chocolates and then remove the number of ways where she puts more than 3 pieces of dark chocolate in the pink box. And that might be something to think about. Alright, so here's what we're going to do. Let's figure out the total number. Oops. Total has 1 L. Total number of ways to just blankly split up the chocolate. And assign to friends. And then we will subtract the number of ways with, let's say, exactly 4 pieces of dark chocolate in the pink box, and the number of ways with exactly 5 pieces of dark chocolate in the pink box. Okay. That might be a little bit easier than trying to split up a whole mess of stuff. Okay, so how is this going to work out exactly? Well, first I probably should look at part A, because that's the one that's asking how many ways can we do anything. So to answer B, we really need to know the answer to A. Now, just in total, splitting up the chocolate, not caring about where's the dark chocolate going, where's the white chocolate going, anything like that, we have 20 pieces of chocolate, and I need to split it into 4 groups of 5. Okay, so that's 20, choose a 5, choose a 5, choose a 5, choose a 5. Okay, because they're all different kinds, they're different pieces and different kinds, different sizes, so we can easily split this up. Now, because the boxes have names, we don't have to worry about distinguishability. So there, I've broken my chocolate up, I've put them in the various boxes. You know, this 5 is going to the pink, and this one's going to the green. And then I've got my 4 friends. Okay. So how many ways are there to assign the boxes to my friends? Well, we can think of it like an ordering problem. If my friends are Albert, Betty, Carol, and Danny, okay, I've got 4 choices for who gets the pink box. And then I've got 3 choices left for the green box. And then I've got, I don't remember the other colors, I'm not going to go back. It's 2 choices left for who gets the yellow, and then 1 choice left for who gets the black box. I can't remember the colors. But 4 choices, then 3 choices, then 2 choices, then 1 choices, that's going to be 4 factorial ways to give the boxes to friends. Okay, so that's the total number of ways to split up the chocolate and assign it to friends. Okay. So we've got that, but now we've got to worry about the things that we don't want to happen. We don't want exactly 4 pieces of dark chocolate in the pink one. We don't want exactly 5. So let's work those out. All right, so I'll start with the easier one. Exactly 5 pieces of dark chocolate in the pink box. Okay. So how many ways are there to split the candies up and assign them to friends if I guarantee 5 pieces of dark chocolate? Well, there's exactly 5 pieces of dark chocolate anyway, so we don't really have a choice. Put all the dark chocolate, so we'll say 1 choice. put all the dark chocolate in the pink box. Okay. And then what do? Well, then we've got 15 pieces of candy left over to split into the other 3 boxes. So that's 15, and then I need a group of 3, or a group of 5, a group of 5, and a group of 5. Okay. So put all the dark chocolate in the pink box, split up the other chocolates however you want. So 1 times 15, choose 5, choose 5, choose 5. Again, the boxes have different names, so we don't have to worry about correcting for any indistinguishability. And then we still have 4 factorial ways, once the boxes are packaged, to assign them to our friends. That doesn't really change. Okay, so there we go. So we'll take that away. What else do we have to do? Okay, how about exactly 4 pieces of dark chocolate? Okay, so what am I going to have to do? Well, I'm going to have to choose 4 of the 5 pieces. Which 4 that go in the pink. Now that almost fills up the pink box, but not quite. Still need, from the remaining 15 candies, choose 1 of them. Choose another chocolate for pink. And then we've got a total of 20 chocolates. 4 of them have been placed in the pink. Another 1 of them has been placed in the pink. That leaves 15 chocolates, 1 of which is dark, but we don't care about the dark for the remaining boxes. So once again, we have got 15 chocolates to split into 3 remaining boxes. Okay, but look at our choices. We actually had to do something with the dark chocolate. We had to choose from the dark chocolate this time. Okay, so here we're going to have 4 factorial ways to split the boxes up into friends. 5 choose 4, 15 choose 1 ways to make the pink box. 15 choose 5, choose 5, choose 5 ways to make the remaining boxes. Putting this all together, we take the total number of ways to break up the candies and subtract off the number of ways where I put exactly all 5 dark chocolate in the pink box, and subtract off where we only put 4, exactly 4 in the dark chocolate, or 4 of the dark chocolate in the pink box, and there would be my final answer. You can take out the 4 factorial if you want, but I would probably leave it as is.